I will start recording again and people will be confused. Okay, well, we added a gearbox. We added some other panels since I paused the recording. So where else would this get weird? So we were pretty okay this year in like putting in rivets and stuff here was pretty okay. Like the tire valve didn't hit anything. I wonder if it might get pretty close, right? It sticks out of one of these holes. So I wonder if it would hit one of the flanges anywhere or something. That would be bad. Most of them stayed pretty well tucked in. And if they didn't, there we could kind of like push them in. So I don't think it's a problem to even like, if we had to, we could probably like tape them in if we needed to. Right? We don't need to get to the tire valve all that often. If we needed to, we could just like run tape across it and force them to stay in their little hole. Let's see, things to consider. So if we're on thinner aluminum, so this is only 16th wall instead of 0.09, right? It's very likely that we may want to add some type of reinforcement plate. So kind of those things that we had catted in 17, right? We had a version of those plates there. We could, and then another thing that we've considered is trying to figure out how to do this well with 25 chain. Like, because 25 chain, one of the things it could do is it could let us get this gap a lot shorter, right? So instead of 3 7/8, we could probably lose at least a half an inch, maybe a little bit more if we went down to 25. Whether that's worth it or not, I don't know. The 35 is so reliable that it seems reasonable enough to give up that internal space. Since we very rarely are doing anything with it anyway. All right, like that width doesn't, the internal width between like the inside of the frame rail doesn't really define too much of our robot. So much of it we can do above it if we need to, by just bringing up a Lexan plate, putting whatever else we want across it. What else do we need to consider in here? So yeah, some of the things we could do in here that we couldn't do before is like places in here where we know we don't have spacers, we could put smaller holes and dimple them, right? We could have like a 1-inch hole or something in here farther away, and make that whole area harder to flex. And it seems very reasonable to do that on our arbor press with even just 3D printed dies if we don't want to buy enough dies. But once we start doing it for real, we'll probably just buy dies. Okay. It does not seem, it seems very reasonable. There's a little bit of like kind of wasted space here. But with the open top, that's less wasted. I guess you have a chain run going right across it, so you're probably not doing much there. Ooh, that actually becomes a problem. So if we were looking at having these standoffs, those standoffs are probably right in the chain path, which is not good, right? We do not want that. Or you can imagine as the chain is crossing from this sprocket to this sprocket, that's pretty close. Oh, maybe not. Maybe that is high enough. So that's the bottom of that chain tooth. Oh, we can probably get something in there. I don't know if you can get a full 7/8, but you very well could get a 1/2 inch thing going across it. Which again, if we had other holes in here where they go between the sprockets, it could definitely work, or between the chain runs. How would I need to look at that? If I wanted to, nope, no hitting. Okay, so if I wanted to make, if I wanted to make this transparent. Hide this one because this is the one that won't exist. This one is too big. So you can kind of see what that chain path would look like. Yeah, so yeah, you kind of have a chain running kind of almost right across the top of this rail, which is a little odd. Right, it would be above this flange at the moment, but probably out of the way of something like a 1/2 inch one going to here. You get somewhere up in there. You could probably run a chain across that. This bottom one, however, is definitely going straight through these holes at the moment. So you couldn't have standoffs through there. That's fine. Again, we can put them up in these spaces. We could find other places to put them if we needed to. Anyone else have other questions? Again, no one has to stay for this if it's not entertaining. Or any other ideas for things we can do to make this interesting? What else would we do to get this completely to where it's reasonable? So I'm trying to think. This definitely gets a lot lighter than our. So just looking at, let's see if this actually, how much this actually matters. So what do I need to do? I need to set material to 50-52 aluminum. That's what all of our bent stuff always is. Applied to the mirrored one. Sometimes doesn't. It did not. Oh, it doesn't really matter. I'm just going to figure out what the weight of this is. Since we know right now these two are the same, we can figure out what the weight of this one is alone. Okay, so this is 0.65 pounds right now, which is not bad. So that whole side is 0.65 times 2, so what, 1.3, where this, assuming it's open, and yeah, so it has its material set. Yeah, that rail, just that rail alone was 3 pounds. Let me double check that the hardness doesn't change anything. It shouldn't, but yeah, so this alone was 3 pounds because we just didn't have any lightning holes and there's just a lot of metal there. It's not like it's very bad. It's weight in the drivetrain. Our drivetrain didn't have, right? None of these sheets were buckling or anything, which is what we were going for. But it's definitely heavy. And then the other side was what? Oh, material's not set for this. What? Weird. Okay. This other side was 1.63. Yeah, so it's like 4.5. It's like 4.6 pounds compared to 1.3 pounds.
That's a pretty big difference.
Yeah, so you're looking at, call it 3 pounds because you figure you may need some other stiffeners and stuff on the other one, right, to make it a little bit bigger. But even if we're saving 3 pounds, that's on one side. So we're saving 6 pounds across the robot. That's huge, right? Like pulling 6 pounds out of anything is absolutely massive. And if we can do that without compromising anything, which I think I think with the flanged holes, with standoffs where we need them, like the places where it gets a little sketchy is right at the wheels, right? Because you have this relatively large unsupported section. So I think as long as we go in and put more dimpled holes kind of in this space, we're probably okay.
Like little inch ones, like 1 inch ones.
Yeah, probably inch and a half, inch and a quarter maybe. If these are inch and a half, you might be able to sneak something in there, inch and a quarter. And it just makes it so these can't buckle very much. And then how we tie these front sides together.
Oh yeah.
Yeah, so if we have a plate across here that ties these together, depending on the season, we might even be able to put some sort of like, there's some things we can do with 3D printing stuff too if we wanted to. So we could come inside this and like tie these together with like a weird shaped standoff if we wanted that doesn't touch the wheel. That gets a little more complicated. That may not be worth it. Say the other thing we can do is where we have this flange, we could, in places where we know the wheel isn't, we could make this deeper, right? So having this be a bigger flange makes this whole thing stronger. So we could come in and with this top flange, make it a little bit farther out, even with the wheel, depending on where the, depending on what it looks like, right? We could definitely make this bigger. But we could have it be bigger even just in here, and be able to tie across the top. Same with over here, we could have this be bigger here, which adds some strength so it doesn't fold there at least. And we can do the same thing across different parts of this. But yeah, getting 6 pounds out is crazy. But we do have to be careful. Again, this is quite thin, thinner than we've ever used before, and we're still taking relatively decent sized chunks out of it to kind of put stiffness back in it. The other thing that we're kind of relying on as well is we kind of assume that there's going to be polycarbonate kind of mounted in these corners, right? So like the handles that we had the last couple of years, right? So we're kind of assuming that it's not just going to be this little piece of this 16th piece. We're assuming there's going to be other parts of the structure that make the whole thing bigger or make the whole thing stiffer and less likely to bend and things, right? Once you get a polycarb piece in here and you rivet it all the way through, this becomes way harder to bend. Which adds weight back, but we already we're using that. We were doing that weight anyway for parts of it, right? Okay. So yeah, so I think there's definitely value in going down some version of this path. Does anyone see any drawbacks to having like the wheels open as much as they are? I think it gets closer to like a West Coast drive, right, where you have kind of the wheels there, which is fine, but we get the advantage of having the plates out here that we can mount to without having to have like the weird West Coast like bumper rails and things, right? Like our bumper rail is just this 16th plate that is part of the whole structure. Depending on, that would get really, you don't want to do that. I almost made a bad suggestion. So I almost suggested like bringing the belly pan all the way across, but there's no reason to do that. And it makes chain and everything really hard. So you don't want that. That would be bad because you couldn't put the wheels in from the bottom without like
yeah, that might get hard.
Like, really sketch chain things. So not a fan of that. One of the things that I was also considering that I don't know if is actually valuable. So assuming we're going to have these like reinforcement plates in here anyway, so what would that look like? So if we had a new part, we don't want to be bolting into just that. I mean, you probably could bolt just to the 16th, but it's reasonable to put a thicker piece of, like another piece of 1/8 or something, or 0.09 even, or just 1/16 even, right behind this to make it so that we don't deflect the axle anywhere if we get like loads on the wheel and you don't like get localized bending right there. I'm gonna make a rectangle at the center, point B, circle. Make it inch by oh, I don't know what number that got. That's way too big. Sure. So if we assume we had this like plate and it had 4 holes or something that we riveted in, one of the thoughts I had was that it could be, if that's riveted in and that doesn't rotate anymore, it's possible that that could be a rivet nut on this plate. So then when you bolt in from the outside, you don't actually have to get to, you don't have to have a nut on this inside. So you'd have to figure out how to make it like a locking rivet nut or something, which gets weird. I'm not sure how that would go down because there are some forms of locking rivet nuts, but most of them aren't as nice as I would like. So it's probably not worth it. But I guess depending on the design, if for some reason we had something where like it was really hard to get to this nut, like we've had that problem before where we, like in the 17 robot, it was kind of like we built this like weird little pocket in here that made getting to this nut incredibly difficult because part of the intake was just like hanging out right here. So we would like drop that nut all the time and it just got really weird. So I guess if we needed to, there's a version of this that you could do a rivet nut and then just put Loctite inside of it, or the Vibratite like brush on stuff that we use to seal things to. So there's probably some version of that would work where we can do this blind, where you wouldn't really, well, you probably don't want to do it just in this sheet because in case it fails or something, it's much harder to remove. Where if you're doing it in this extra little sheet, you drill out these rivets, and you could just put a bolt in if you needed to, or you have a spare plate that doesn't have the rivet nut hole or whatever. So if something does happen, you're fine. Where, so if it's in that main sheet, it's much harder to deal with if something gets weird and it starts spinning or whatever. One of the things I haven't been able to see if anyone does, I've not been able to see like any projects where people dimple dye polycarbonate. But there's no reason why it shouldn't do the same thing. I haven't figured out I don't know why. No, I haven't found anyone who's done it. Like I did, I mean, not an exhaustive search. Like I'm sure there's probably something, but all of my Googling and YouTubing has come up with nothing, which makes some sense because most people don't use polycarb structurally very often. Or if they do, it's because they want a solid sheet, right? A lot of times it's because it's clear and all that stuff. Where we do it because it's easier to manufacture, because we can laser cut it. Most people just don't do that, and they just figure out how to do it out of metal if they need it to be stiffer. So that is definitely something we could play with, as well as figuring out how to do dimple dyed polycarbonate sheets. That could potentially add some stiffness into the middle of panels where we don't have standoffs. There's also forming where you don't even cut the hole, which is a little bit weirder in how you like figure out how to stretch it. It works with much thinner metal better than it works with thicker metal, but you can like just add dents and things just by like stretching the metal up a little bit. That also adds stiffness, but that gets a little weirder and you have a much greater chance of like tearing the metal. But one of the things I am wondering if you could do this is completely like, I hope we're never doing this because at that point we've gone.
We're too far gone.
We've probably gone too far, but I'm pretty sure if we heated polycarb and pressed it, we could form whatever like 3D structures you want into it, right? So you could form a dimple or like a bump or whatever. Because once you heat polycarb, it'll stretch.
Yeah.
So I'm pretty sure you could like make a very rigid 1/8-inch polycarb panel with lots of different like either rails or they're not quite louvers because louvers normally have like a hole in it, but some sort of dyed pressed internal flanges in the side of polycarbonate sheets that probably requires heating it and then pressing it, which then if you're trying to like press it with a 3D printed part gets awkward because now you have a heated plastic with this non-heat. That's a problem. So if we like routed aluminum dies to do the pressing, that would probably work. And then like heating those dies and pressing the polycarb and making and just it shouldn't stick. It's pretty good about not sticking. But again, that's probably farther down the road than we want to go down. But it probably works. I don't exactly know where we'd want to do it. It's probably something like the side of our intake this year.
Oh yeah.
Could have stood to be a little stiffer. Where it was relatively stiff because we had enough of that box structure with the spacers, but we could have definitely potentially made those panels a little stiffer and still been impact resistant. There's some balance there between too stiff and then at some point instead of just flexing it cracks, which is what you want to avoid. But ideally, if it's polycarb, it'll try to bend and deform. It just makes it slightly harder to do so if we have those bends in it. Even just potentially just starting to put more flanges along the outside of the polycarb panels may help.
Yeah.
And that's super easy to do, right? We do them in CAD and then throw them on our brake, and we don't plan to put any holes in them or anything, right? So you just bend them up and you don't really care where they are as long as they don't block any other feature. That alone will start making stuff, especially the edges, stiffer in places where there aren't spacers, so those edges won't collapse as easily. Okay. I'm trying to think how far I want to take this today. So I think most of this, I'm trying to think, are there any other places where we're going to run into problems, right? So as long as we have places where we can bolt it, but we can definitely figure out places to mount it. We don't get too crazy with making sure we can mount the motors, which is always a little weird, but we're pretty okay there. It's not different. It's not that much different than this year's in that regard. Right, like ideally you're not blocking the motor mounts with tires, but if we end up doing that, you just end up doing that and it's fine. Because we have bolts and nuts that we just can take off and pull the whole gearbox if we need to. We also haven't broke a drivetrain motor in a while. It's pretty rare. We say that and eventually it'll happen, but it's relatively rare. And it's easy enough to pull the whole gearbox in our configuration that's by far the easiest thing to do. Because yeah, we have it set up that only these 4 outer bolts are the only thing that mount it. So you can just pull these 4 outer bolts, and then as long as you pull the sprocket off, the whole thing can just come out.
Yeah.
Which is very convenient compared to having to like actually undo parts of it. And it lets you build the whole thing before installing it too, which is nice. Oh. Okay. What else? I'm trying to think where else we'd run into issues. So yeah, there are some chain clearance stuff. Oh, that gets a little awkward. That's a lot awkward. So it's very likely that is hitting chain right there. right? I'm pretty sure.
Oh.
What am I gonna do? What is that?
Ooh.
So that distance is in this model, which I think had some extra space, but I'm fine with having some extra space because we don't want to do anything too bad. Is that normal distance 147? That sounds right. I think that's what we have in the our design sheet has that number somewhere too, I think. Double. Oh, our design sheet has it as a much bigger number. No, it should be a much bigger number. How did I get that number? That number doesn't make sense. The number in the design sheet is 0.236. How did I get the number I just got? That doesn't seem correct. Oh, it's center line of sprocket. That makes sense. Never mind. Yeah, so center line of sprocket to this chain edge is 236 in our design sheet. So that would put this at 463. Yeah, close. That's probably about right. So yeah, so right now we are definitely too close here. Yeah, for sure. That's 0.09. That chain would not be happy. So all that means, though, is that we have to shift this sprocket further down the output shaft. And then we would have to move the wheels over, which does get this outside of the wheel and where the valve stem and stuff is closer to this sheet. So we have to be careful how we do that. And then we have been so this year we did just run the actual Vex half-inch spacers. There is a little bit there, like that's slightly more than you actually need between two chains. Like we can look at it on the real one and see how close they are, but they half inch is the easy standard and it works. But if we wanted to, we could take out a little bit of space in between each sprocket and between the sprocket and the wheel. Maybe not between the sprocket and the wheel because the wheel actually comes over a little bit. So on this one, at least, we could probably go a little bit closer. It's also probably not worth it. Right? Like the whole robot does not dramatically get that much worse if instead of 378 between here, we switch it back to the 2-inch number that I had originally. Like if that becomes 4.
Oh yeah.
Right, we get that extra 1/8 of an inch. We move the whole wheel over 1/8 of an inch, and we're pretty close to okay. And that doesn't change that much. So instead of what? So how did we make this? I think I just made it to that sprocket, and I don't want to change that sprocket. So I'm going to get rid of that coincident mate to there and make it. Oop, it did very bad things. Let's not do that. That's just not good. Okay. I know. Okay, less bad things. Wheels are back where they're supposed to be ish. And then we're gonna we added a whole 1/8 of an inch into here, so we can add a full 1/8 of an inch into there. So now that's still only 0.21. So that's probably still hitting. Oh no, it's not. No, it's not because we said it was like 0.16 something, right, to the edge. It's 0.2 something to the center line. So we're probably okay there. So that's probably about, and that got us our 1/8 back. So now we're the same distance from here to the wheel, a little bit more here. And we would just have to change the spacing on this, right? We would have a different spacer back here. We'd add 1/8 of an inch back here to kind of solve that. Less bad. And now we're making, we're making 4-inch standoffs here. So with a 4 1/4 bolt, you only have 1/8 of an inch sticking out. That's less good. Oh, plus once you have these plates and stuff, yeah. So you probably have to get to at least a 4 1/2 inch bolt instead of a 4 1/4 bolt, which is not a big deal. That does not change that much. What else? Yeah, so I think then the only other issue is the fact that our reduction is kind of meh. Let's see what our speed thing looks like. Where do I have that? That should be in the GrabCAD for this year somewhere. Jack had a spreadsheet for the drivetrain. Here's an iLight calculator version, and he has that version. Okay, is this the final version that we were running in? I think this is where we're doing drivetrain. I think we have a different one where we're doing climber. I'm gonna switch my share screen in a second. Make sure that that's true. Okay, yeah, okay, so let me, okay, so this Excel spreadsheet is how we figured out our drivetrain ratios and speeds for this season. So yeah, so we had, it's labeled Neo, but we had gone in and changed all the specs to be that of a Falcon. Okay. The robot weighed more than that. It's probably not the full 150. It's probably like 140, but okay. And then the part where this gets odd is the chain reduction is always up here. Was that 34? Why does it say 32? Did we not update this? That's interesting. We're going way faster than we thought we were going. Maybe we didn't save this at some point. Okay, well, at some point, this is what we ended up going at, which definitely gave us a higher high gear than we probably wanted, and a reasonable low gear. Changing this gets a little awkward. We ended up doing, oh no, this is definitely not updated because we did something different in here at some point. So I have to go back and kind of figure this out. So I think we swapped that to an 11. It says 10, but I think it's actually an 11. So this is weirder than I want to get into, but basically we did 10 to 54 is that pinion transmission. It's 10 to 60. I have to remember how our gearbox works. Okay, let me flip the share back over. Okay, so the way this gearbox works, this weird 1.5 stage thing is, in one of them, it's just this reduction, which is 10 to 60, and then out to the chain reduction.
Okay.
That part's easy. And that is 10 to 60, right? That is what that says. Yes, that is the 62. Okay, so that's 10 to 60. That part's easy. The second reduction is you get this idler reduction bit that goes 10 to whatever the idler is here. So yeah, the 60 doesn't matter anymore because all it's doing is it's just acting as an idler. So it goes 10 to whatever this gear is, and this gear in this case is an 11 on the real one. It's catted as a 10, but it's really an 11 on our actual drivetrain. And then this gear to the ball shifter gear, and that should be the 18. Okay, so that means that is the one that changes everything. So it's like 11. Okay, so if I flip back to the spreadsheet, let's see. So those are all just written values, right? No, that's pulling that one. This one is written, so this one should be 11. How is this getting calculated? So this is, yes, this is 11 over 10, 54 over 18. That makes sense. Is it white? That's weird. I don't know what's happening there. All kinds of weird. Oh, stranger. What is going on?
Yes.
All right, I'm just not even going to try. I don't know what's going on. This is not our spreadsheet. I don't know what's happening here. Okay, either way, this is closer to what our split is on the robot currently, which is like 17 and 9 or so. So the places we can adjust easily are the pinion gear here, which should be taken from there. So yeah, so that's the pinion on the Falcon. So that can either be 8, 9, 10, 11, 12. And this gear, which can either be 10, 11, 12. So as we move this up, our top spree speed gets bigger. If we move that to 12, it gets a little lower. So we can get down to a 15 in our high gear, which is probably more reasonable. Like, we should probably make that change on our robot. Like, our high gear right now is probably a little too high. And then that's not terrible for a low gear either. So our 9, that 10 is probably pretty okay, 1232. But if we wanted to start swapping this down further, if we made this sprocket smaller, that starts changing everything else, right? So we don't get that much bigger, but there's no easy way to just drop this speed once this is already at 12. Because anything else, because everything else gets really weird because you have to, what do you have to do? So as long as there's a 6-tooth difference, these two gears can be the same, or these two gears can exist. But I don't know what that changes, right? Because the spread can't get any. smaller anymore, right? Like you could do some weird like 1320 thing, but I don't think that changes much. Yeah, that didn't change much. That meant 20351 instead of a 36. Yeah, that got worse. Yeah, so the 1218 I think is the farthest you can go, because it's always going to be that 6-tooth spread. And anything else is going to get bigger, I think. There's probably some really weird like 914 thing that could, or no, 916, but I have no idea how you'd even do that. It's like some really weird thing. That doesn't actually even help you. Oh wait, no, just the wrong number. Oh, it still doesn't help you. Why does that not help you? Oh yeah, no, that makes sense. Yeah, that just makes it faster. Okay. Everything else you do here also makes it faster, right? Oh no, 1420 is bigger. How much bigger? So that just gets the spread closer together. So basically like our shifting does less, which isn't necessarily the bad thing. How much more could you do? You could do 1622. Interesting. So yeah, so there's some stuff you can do, because as long as these are 6 teeth apart, they're still possible to mesh here, right? Because this is 54 and this is 60, so you just want, these just have to be 6 teeth apart so they can still each touch, and this thing just gets further away from it, right? This shaft would just like move further this way the more you did that. Eventually you run into some problems like the spacers and things, but you could change that shape if we needed to. Oh, I forgot to do the new share. What I just said made no sense because you're not looking at SolidWorks. I apologize.
Well, I understand what you meant. I was like,
Yeah.
he's not sharing, but I understand what you mean.
Oh. Yeah, that gets interesting. Okay. Okay. So there's no version of that gets us all the way to like 1222 though. 1222 is stupid fast. Yeah, it's like 20 feet per second and 13 feet per second. That's like a lot. Unless we moved this up a lot more, like at that point you have a 24 tooth gate in there. That's really big. Yeah, that doesn't help you. Does not help you at all. Very little. Okay, so, but yeah, 1824 actually has its advantage, which is that it could run entirely on you can run actual gears without having to do any weird modification. Because right now we have to like cut a pinion in half. Oh, I guess you don't even have to do that. What's the smallest 3/8 gear that exists? I'm assuming. Let's see. Share. Gears. Yeah, so they have a 14 tooth. They have a 14 tooth and a 16 tooth in 3/8. So you could do 14 you could do 14 or 16 as a 3/8 hex shaft, which is easy enough to do. And then I think they have the aluminum 3/8 gear in whatever size we want. Yeah, so then you have, yes, you have anything from 14, 16, 20, all the way up to whatever you need there. So if we did do 1622 is very reasonable to do if we wanted. Same with 1420. And it's actually a lot easier to do than what we were doing. And both of those get more reduction than we had before. Wait, that's not, yeah, that is right. That's 6. Okay, so yeah, then the crazy thing that we can do, which isn't too bad, is you can drop that to an 8, which is the 8-tooth falcon pinion. And now we're back to 1016, which is kind of where we want to be. And we only have to do a 1222 reduction in our chain reduction. Interesting. We probably want to go a little bit more. Maybe not. It probably doesn't matter that much. Yeah, so you could do 24 or something, but it probably is fine doing 22. It says our weir slip current is like 70 amps per motor, which is reasonable. You figure our 6-inch wheel isn't necessarily exactly 6 inches. It could be more, and that changes our speed quite a bit, right? That's one of the kind of weird things about this whole thing. Or if it gets smaller, it changes your speed quite a bit. Depending on where you're at, you can, because you're spinning those, right? This is just the diameter change has such a big impact on your actual final speed. Okay, so that's interesting. So yeah, there probably is a version of this that is 1222. We have probably less adjustments that we could make, because the only real adjustment you could make is if you wanted to go faster, you could up this to a 9. Then we're probably too fast, 1218. Yeah, we lose our adjustability at this gear point because you can't. Well, I guess it's not even that bad, because even if we wanted to adjust this gear ratio, we would just have to make new backplate. I gotta remember to flip my sharing, or you need to yell at me if I'm saying weird things that aren't happening on screen. The 1622, we can't adjust, because before in this season, in theory, we could have adjusted this, but all you have to do is make a new gear plate that has the right spacing, which isn't that bad. Like, we're not like we're adjusting gear ratio at an event or anything ever. That'd be rough. So that lets you do, what's the advantage? You get smaller sprockets out at the wheels, which are fine. Like, bigger sprockets in theory are better in that you have like more teeth engagement and other things, but we're not breaking our sprockets. Like, we've never ripped a sprocket off on a drivetrain no matter what we did, especially not at 35. So 1222 should be fine. I wish they had somebody sold an 11-tooth sprocket. That'd be very convenient. I'm pretty sure an 11-tooth like works fine on a hex, but they're just not. No one sells one. It would be very useful. Because we could definitely get like all of our, everything gets much tidier at 11. Yeah, one of the reasons we didn't do this is we were worried about Falcons, and we wanted to make sure we had Neo backups, and 10s are far, and you can't do 8s on Neos. You can do 9s, but they're weird in press fit. But you can do 10s really easily. But now that we know we're probably Falcon forever on our drivetrain. 8s are totally fine to design to now. $10.16 is like it's a reasonable spread. There's a reason to shift up into high gear. Like we would definitely get. I don't know if it's actually that much more reasonable. It may at some point just not be reasonable to have. Because the other option is we just get rid of shifting.
Wait, did Jack say that he shifts it a lot?
No. In this game, no. Like in this game, I'd be very fine not having a high gear. And we would never really worry about it. Because our low gear is so high anyway, it's not that big of a deal. There's probably games where we want to be able to go faster. 17, where we're like doing full court runs the whole time.
Oh, yeah.
But even then, it's probably not that important. Yeah, with as much low-end torque as like the Falcons and stuff have, and you accelerate so quickly anyway, it might be easier if we just got rid of it, right? Everything, that whole gearbox gets so much smaller if it goes away. Back over. So if we don't shift at all, right, we basically just stay at this. This goes away, this shaft goes away, the pneumatic cylinder goes away, and we basically just keep the 8 to 60. You just keep this one low gear speed. So this whole thing gets brought in. It weighs less. That's 12 to 22. Yeah, depending on what we do with our, if we add back in some ground clearance, we could get this flange above this sprocket. So we could pull this back in a little bit if we wanted to. I feel like we get annoyed when we don't shift, but we also don't use the shifter.
Yeah.
So it's a weird problem of, do we actually care? Because we were running in low gear so much this year, but it's fine. Like we weren't using, if we just don't, if it's the opposite where you need a low gear and you don't have it. Like if we gear too fast, but if we just are okay driving at this like slower-ish speed, it doesn't really affect us that much. I don't know. We also didn't get to play a full season because that was part of the goal, was to be able to eventually get enough driver practice to where we were using where we were using that faster speed. And it doesn't add that much complexity to everything, right? Partially because we're just buying the shifter shaft, it means it's actually a shaft we don't even have to make, right? Because it exists. You have to make this shaft, but that's not too difficult. Those bearing holes get a little bit, actually they don't get bigger, they get, because they're catted wrong. Oh no, we have the right bearings in there now. Because there's 7.5, and then we'll actually go to, they're 19 millimeter on what we own, but then we'll go to like 7/8 once we have a 3/8 hex in there probably. Oh no, it'll be 3/8. Yeah, it'll be 3/8 round, and then we'll just turn down the hex. But yeah, there's room for that. It's fine. But yeah, there's not that much difference. Oh, and I guess in theory we can, if we ever decide we need the weight, pulling it and replacing it with the single speed is very, very easy. Right? Nothing dramatically changes other than what this gear pilot doesn't exist anymore, but that's not a big deal, right? Like in the new plate, it would just be the same size as the normal bearing. where the output of the ball shifter is this like giant bearing thing because it has to have this 3/4 shaft has to fit in it. But that's not a big deal. It just gets smaller, which is fine. So yeah, so in theory, you can always design for this, and then if you have to ever swap in a single reduction because you want the weight, or you just decide you want to do it. Like we could make a single reduction version first even, and then add in the shifting version later if we wanted to.
Yeah.
As long as you just leave, well, I guess you just wouldn't be able to save that little bit of like that 1/2 inch of room or whatever it is, 3/4 inch of room. Because you could make this whole thing slightly narrower. You could bring these plates closer together if you didn't have this extra gear, but that's basically it. Because you're not using this room between the motors for anything, hopefully. Where this pneumatic is. If you start mounting things there, we have a different problem. I mean, I guess you could, but that's kind of scary since eventually we do need to take this gearbox out.